Okay, good day class. Our lesson for today will be Module 3, wherein problems, reasons, and solutions in mathematics are the covered topics to be discussed. Here, for Module 3, there are two lessons that we are going to discuss. Lesson 1 will be allotted for inductive reasoning, Lesson 2 for deductive reasoning. We will try to find out the difference of these two and be able to distinguish among them. Okay, we will try to find out some statements to be noted. A profound understanding of problems leads to a better solutions. The problems and solutions alike vary and may range from simple to difficult. Mathematics provides the central piece that allows one to discover ways to come up with a practical solution by Manlulu et al. 2019. Competencies at the end of this module, the students will be able to demonstrate abilities of reason and logic to arrive at a solution, analyze information to develop reasoning skills, distinguish the inductive reasoning from deductive reasoning, and utilize inductive and deductive reasoning to solve various problems. Moving onwards, for Module 3, again, like I said, there are two lessons. Lesson 1 will be inductive reasoning, lesson 2 for deductive reasoning. Intended learning outcomes for this module, that is for a particularly module 3, at the end of the lesson, students will be able to draw the next pattern using inductive reasoning. Okay, usually this pattern, you can encounter this when you took your entrance exam. This is under analytical skills, I think. No, analytical skills. You will be measured there. How good are you? Okay, and then you are also expected to be able to determine the next three terms in a number series. No, and then write conjectures using inductive reasoning. So what do you mean by conjectures? Okay, conjectures is that an opinion or conclusion that is being formed based on an incomplete information. Okay, that is what a conjectures are. Okay, so we'll have the introduction. Mathematical reasoning stems from understanding problems. It is how the problems are observed and analyzed. From this analysis, problems can be solved with relative ease. There are multiple ways to solve a problem. Remember, there are multiple ways to solve a problem based on the language you have learned previously, the language of mathematics. Okay, this is a conversion or conversion from an English statement and have it converted into mathematical statement in forming an equation and other algebraic expressions. So here again, there are multiple ways to solve a problem. Since you know already the language of mathematics, we learned that previously on the previous modules. So we're ready for this next level. Information is very critical. This will be the basis of your solution. So like if you can still remember um, the worded problem, you're going to have it converted into mathematical equation. Okay, so information there is very critical for you to be able to form the equation and solve the problem being asked. The more information you gathered, the more practical and reasonable the solution will be. Manlulu et al. 2019. A good problem solver is one who can find a solution of which the path to the answer is not immediately known. A good problem solver uses a strategy which cannot be learned through school drills. In the real world, decision making and problem solving are two key areas one should be good at in order to survive. Baltasar et al. 2018. So in the real world, there are two things, no? The key areas that one should be good at, no? Decision making and problem solving. These are the two skills that need, let's say, if you are a manager, you must have these two skills especially. No, you must have a decision making and a problem solving capabilities or skills. Moving onwards, on this activity, you're going to try this. What comes in your mind when you hear the word mathematics? Okay? Anong pumapasok sa isip nyo? No? What comes into your mind? List 5 statements that describe mathematics. Based from the statements, what can you conclude about mathematics? So, this is, you are tasked to make a conjecture, no? Conjectures. Okay, what is a conjectures? It is an opinion or formed ideas to based on incomplete information. Okay, so let's say what comes into your mind when you heard the word when you hear the word mathematics. So probably let's say mathematics involve numbers. What else? Mathematics deals with daily solution in any problems encountered in the real world situation. And out of that, since you were able to have that opinion or formed ideas, then what will be your conclusions, no? Out of your opinion. So that is what we call conjectures, no? So that is under this activity, no? You're going to make some opinions, and out of that, you are going to conclude based on the opinion that you have um, listed. No, let's say if there are 5, then what's your conclusions about mathematics? Okay, for analysis, okay, under analysis, here where inductive reasoning comes in, it is the process that uses specific examples to reach a general solution. Okay, the conclusion formed by the inductive reasoning is called a conjecture. Like I said, conjecture, okay, it's a conclusion or opinion based on an incomplete information. Okay, Baltasar et al. 2018. A conjecture is an idea based on incomplete information. Ito na. This may be true or false. In this case, counter examples are very useful to prove the validity of conjectures. These are statements that contradict the claims of conjectures. Manlulu et al. 2019. So inductive reasoning, take note of these two keywords. Okay? Coming from a specific case to general principle. That is inductive reasoning. Okay? From specific to general. Okay? The following examples of inductive reasoning are listed below. Number 1, use inductive reasoning to predict the number in each of the following list. 3, 6, 9, 12, 15. What's next? So solution. So add 3 to the preceding number. The next number in the list is 18. Okay? So this is a specific statement. Add 3, no? Add 3 for every preceding term or on the preceding term. Then the next number in the list is 18. Okay? So this is the general principle. The next, no, number. Solution, first two numbers. Okay, solution meaning this is the answer itself. The first two numbers have a difference of 5. Okay, so this is for letter B, no? So the first two numbers have a difference of 5. This is specific. information. The second and third numbers have a difference of 10. Continuing this process, the difference of consecutive numbers is a multiple of 5. Therefore, the next number in the list is 76. Okay. Number 2. Miss Angel is pretty. She is smart. She is my math teacher. Therefore, all math teachers are pretty and smart. So this is a general statement. No, this is a general statement. These are specific or particular statements. So from specific to general statement. The teacher used PowerPoint in the last few classes and also before our class. Therefore, the teacher will use PowerPoint tomorrow. Okay. Max is on vacation in Zamboanga del Sur. As he is traveling, he sees only rice fields. Max concludes that the only thing grown in Zamboanga del Sur is rice. Verify that each of the following statement is incorrect by giving a counter example. This one. Okay. X over x, we know if we divide x divided by x equals 1. But a counter example can also be specified that what if x is equal to 0 over 0, and this is what we call undefined. Okay, that is not equal to 1. That is undefined. Okay, so this is not equal to 1. 0 over 0 is undefined. There is no answer. Okay, take note of that. But other values for x, that will be true for this statement, except only when x is 0. That is the solution here. When x is 0, this implies that x is not true for all x. So not true for all x. This is what we call the counter examples. Counter example, to be specific. This contradicts or disproves the conjecture that x over x equals 1. Moving onwards, okay, for this expression, no, sorry, equation for x equals 1, the square root of x squared plus 4 equals square root of 5. Okay, so the problem here is for letter B. No, this is the equation showing that square root of the quantity x squared plus 4 is equal to x plus 2. Okay, let's see. So if we are going to assign value of x equals 1, the value for the left member, this is what we call the left member of the equation. This is the right member of the equation. If we allow x to have a value of 1, you will have that 1 squared plus 4 on the left member of the equation. On the other side, for here, we have x plus 2, so that is 1 plus 2 if we assume the value of x equals 1. Ending up to be 1 squared is 1 plus 4 equals 3. 5 is not equal to 3. So, sorry, this is square root, right? Okay. So square root of 5 is not equal to 3 implies that this is a false statement. Okay, take note of the conjecture. Okay, it may be true or false. Take note of that. Information may be true or false, or incomplete information. That's what a conjecture is. Okay, moving onwards, for abstraction, use inductive reasoning to make a conjecture out of the following process. Consider the following procedure. Pick a number, any number you want, and then multiply the number by 10, add 8 to the product, divide the sum by 2, and subtract 4. Okay? Repeat the procedure for several different numbers. Make a conjecture between the relation of the size. Take note, here you are tasked to make a conjecture. Okay? A conclusion between the relation of the size of the resulting number, the size of the resulting number, and the size of the original number. by way of inductive reasoning. Meaning you are going to compare, repeat the procedure for several different numbers. Okay, so I will make specific numbers here, at least five specific, uh, five different numbers. Okay, by following these 5 steps. Let's say, pick a number. How many of that? Sabi ko is you have to pick at least 5 numbers, no? So you have number 1, number 2, number 3, number 4, number 5. Then what are the results here? So what will be the following? By following these steps, you will arrive the values based on the peak, based on the based on the numbers that you have selected. Compare the size of that to the resulting number. Okay, so next, for the application, okay, draw the next figure inside the box provided. So you are tasked to draw the next figure inside the box provided. Okay, so for number one, for this box, you have sequence number 1, sequence number 2, sequence number 3. What is the sequence number 4, and put it in the box. Okay, so you're going to draw, so maybe some of your classmates may ask, sir, how are we going to draw this one in Microsoft Word? You just have it handwritten, then just take a picture, then attach it here. Okay, so that it will be easy for you. Okay, if some are using paint to draw the figure. So if you find it hard, just make it by hand, draw it by hand, take the picture and attach the image in this box. Okay, the same is true for number 2. I think the pattern may be, what is the pattern that you have observed here? It goes to the right, up, down, left. What's the next pattern here? Okay, also the star here. What's the pattern? What is your answer here? Okay, the same for number 4. You have the pattern 1, 2, 3. What's the fourth pattern, and put it here. The same here for number 5, pattern 1, pattern 2, 3. What's the fourth pattern here? Put it here. Okay. Okay, continuing for letter B, also use inductive reasoning to determine the next 3 terms in the list numbers below. So observe the pattern. So you are tasked to fill the blanks, the 3 spaces provided here. Okay, there are 3. For every number, you have to make 3 series of numbers based on the observed, let's say, difference or another pattern. Letter C, write your conclusion based on the given statements. So for number 1, so Nikki's cat does not like to get wet. Carlos' cat does not like to get wet. Therefore, you make the inductive reasoning. Okay, so again, for C, write your conclusion based on the given statements. For number 1, Nikki's cat does not like to get wet. Carlos' cat does not like to get wet. Therefore, so what will be your conclusion here? My math teacher is strict. My friend's math teacher is also strict. Leah's math teacher is also strict. Therefore, what will be your statement here for conclusion? Number 3, Mr. Sanson is physically fit. He is a PE teacher. Therefore, what will be your answer here? An even number is divisible by 2. 64 is an even number. Therefore, blank. So what will be your answer there? Okay. So take note of inductive reasoning, ha. So inductive reasoning is coming from specific going to general principle or statement. That is inductive reasoning. For number 5, Jessie's mouth swells whenever she eats shrimps. She gets rashes when she eats clams and crabs. Therefore, what will be your general statement here? Continuing, Okay, so summary. Inductive reasoning is the process of making general conclusions founded on specific examples. These conclusions are called conjectures. Counterexamples are statements that opposes or contradicts the claims of conjectures. Take note, conjectures, this is based on the incomplete information. At the same time, it may be true or false. That's why it can be contradicted but through what we call counter examples. Okay, so continuing now, so for module 3 lesson 2, no, the opposite of inductive reasoning is deductive reasoning. So let's try to find out what is a deductive reasoning. So before that, the intended learning outcomes at the end of the lesson, students will be able to use or identify the missing numbers using deductive reasoning, write conclusion using deductive reasoning, solve problem involving deductive reasoning. Introduction. Mathematical reasoning can sometimes lead to observers to make impractical decisions. If the event happened already, what evidences can be made to justify the event? Information that have already been verified are important to prove the validity of reasoning. This is the reason conjectures can be transformed into generalized principles. Manlolo et al. 2019. So let's try this. No? For activity, find the value of x, write the reason for each step in the process. Okay? So you're going to solve for x for number 1, for number 2, and then we'll go to analysis. So before finding the value of x, I will explain you later on the principles involved in solving the unknown for, let's say, for the variable x, no. And then for this activity, again, you are tasked to write the reason for each step in the process, no, the reason. Okay, so you're going to find x first. You're going to what? Solve for x, no? Anyway, I'll discuss that later on, but for the meantime, you're going to do that as part of your module. I will give you the explanation or the principles involved for finding the unknown variable, the value of the unknown variable, like for this instance, variable x. For the analysis, no, what you did in the first activity is called deductive reasoning. This refers to what you've done here, no, for 1 and 2. So what you did is not inductive but deductive. Why? We will know here. Okay? Deductive reasoning is a type of reasoning that uses facts, rules, definitions, or properties to arrive at a conclusion. So you are now applying the general principle to arrive a specific solution or specific case. So unlike in the inductive reasoning, you are giving specific examples and arrive at a general principle. General. So again, the difference between these two, now we were able to distinguish that for inductive reasoning, okay, from specific to general. Deductive reverse, no, from general to specific case. And take note for deductive reasoning, you use the general principle, no? It means when you say general principle, it is already a proven facts, no, or rules or definitions. Meaning to say, this can never be an inductive reasoning because you are now applying the rules of, let's say, the distributive property in multiplication. These are facts. These are principles involved in mathematics. and simplifying the value of x by performing arithmetic. When we say arithmetic, you subtract, you add, you divide, you multiply. These are what we call arithmetic operations. So these are rules. So once you use rules and come up with a solution or a specific case, this is what we call a deductive reasoning. So the following are examples of the deductive reasoning. All numbers are divisible by 3 if the sum of the digits is divisible by 3. Okay? Consider 459. The sum of 4, 5, and 9 is 18, which is 18 is divisible by 3. Therefore, 459 is divisible by 3. So the general principle here states that all numbers that are divisible by 3, if the sum of their digits is divisible by 3, this cannot be what we call, there are no counter examples for this because it's already a general principle. It's an accepted facts that cannot be disproved. So this is what we call the deductive reasoning. No, all men are mortal. Robert is a man, therefore Robert is mortal. Okay, what is meant by mortal? So mortal is in Tagalog namamatay, no? So subjected to death. So these are accepted facts. Everybody's going to die. So this is a general principle and specific case. No? Number 3, use deductive reasoning to make a conjecture. Consider the following procedure. Pick a number, multiply the number by 10, add 8 to the product, divide the sum by 2, and subtract 4. Solutions are given here. Okay. So we started with n and ended up with 5n after following the given procedure. This means that the given procedure produces a number that is 5 times the original number. Okay? So, use deductive reasoning to make a conjecture. Okay? So, from general principle to specific. Okay? So, make a conjecture out of that by way of deductive reasoning. Moving onwards, then abstraction. Consider the following conjectures. Negative 3x minus 3 equals 10. Then, again, why they use here, what is this? 5 times 2 equals 15. Okay? They're not supposed to use x here anymore. Okay? So, in the language of mathematics, we are no longer allowed to use x. By the way, to make it clear, this is 5 times 2 equals 15. Okay? So check for that. Just like this one, 3x minus 3, this is okay. No, solve for x. This one. Also here, 1x. I think this must not be the case, no? I have to check this one. It should be, let's say, 5x minus 2 or 5x plus 2. Okay? Okay, I believe this must not be 5 times 2. It must be 5x. I will be the one to make this a problem here. Take note of this. Better have 5x. Let's say minus 2. Okay? Okay, 5x minus 2. The problem should be 5x minus 2 equals 15. I will be the one to make the problem clear. No? Maybe the operation, they forgot to include the mathematical operator here. So 5x minus 2 equals 15. This is the problem, okay, for abstraction. The same is true. This one x. This is not 1x. Should only be x, no? It's already understood for x to have the numerical coefficient is 1. So x minus 9 equals negative 84. Another problem here. Okay, I'll check this one first and then I'll come back to this problem. Okay, continuing, no, the problem here, I notice it seems to me this is not variable x, no, it implies an operation. So consider if we are going to remove this, okay, for a while, I'll remove this again, this one. Okay, so consider this problem. This is not x, but this means multiplication, because it's written away from the number. Okay, but like I said, we already introduced the dropping of multiplication symbol because this may be interpreted as variable x, but still they introduced this one. But anyway, this one indicates multiplication. Okay, they should have it written this way. But anyway, for the time being, consider this as multiplication. Okay, this is a conjecture, and you notice that this is another problem here, and then another problem here. Okay, these are conjectures. Then do determine the solution for this one. No, below also. So conjectures here, 24 times negative 3. How much is that? Anyway, you need to place the answer here, but I need to discuss a separate video for the principles involved in dealing with arithmetic operations and other arithmetic solutions needed to be solved for a problem on the given problem. So in the application, here we have the module to introduce you on how to play Sudoku. Okay, Sudoku is a 3 by 3 puzzle such that numbers 1 to 9 are placed in each of the box only once per box. Meaning only once means you only use numbers from 1 to 9 once. No, you cannot repeat within the box, row and column. Solving Sudoku using inductive reasoning is not possible. Why? Because every grid is unique. So if you try to understand, once you know how to play Sudoku, you will understand why inductive reasoning cannot be used, but instead it should be deductive reasoning. There is no specific rule to follow to get to complete the grid. There's no specific rule. Therefore, deductive reasoning is used. Sudoku puzzle below. Okay, what is a Sudoku? No, it's actually a 3 by 3. We call this. Let's say we call this one block. This is a 3 by 3 puzzle, and a 3 by 3 also blocks. So we have boxes here in one block. We also have 3 by 3 blocks, no? One block, two block, 3, block 4, block 5, block 6, block 7, block 8, block 9. Okay? So they said that numbers shall not be repeated within the block. You are going to place, you have to complete the numbers 1 to 9. At the same time, it has to be, you have to make sure that numbers here from 1 to 9 also will not be repeated. The same is true here, will not be repeated. That is how to play the Sudoku. I gave you the video tutorial for Mr. Sudoku videos, that you are given some techniques there by introducing what we call the principle of top, middle, and bottom principle. And we also have the columns left, center, right. Okay. principle and the RAM principle. So I think I gave you in the classroom the link. Let's check this out. Here, go to classroom. Okay, the Sudoku. Okay, Sudoku guy, no? So you are tasked to watch the 25 lessons because these are the techniques on how to solve the puzzle for Sudoku, no? This is for the lesson 1. So here you notice you have the TMB here, no? So the first lesson 1 teaches you how to use the TMB, the top, middle, bottom. Okay, the top, middle, bottom principle. Okay, so you have top, so meaning the top is this one. You're going to check this, the top, the middle, the bottom. You are going to complete in each block from 1 to 9 by not repeating the numbers. You are allowed only to use numbers 1 to 9 once. At the same time, along the column, it must not be repeated also from 1 to 9. The same is true on the rows. Okay, columns downward, rows to the right. Okay, so there are 25 lessons for you to review because you will be assigned in a, you will be grouped, and then you will be competing each other, and then you will be graded accordingly. Okay, so again, we have now the top, middle, bottom principle. We have the left, center, right rows principle, and the ramification. He calls this ramification. As you try to apply these two principles, then the third one is the ramification, no? You also have what we call the matching pairs, no, by writing like this, 1 2, let's say. So we call this matching pairs. So you will learn that as you go along with the 25 lessons introduced by this Sudoku guide. Okay, continuing. So just watch that one, no, in this link. You are given the link, just click on that, and then start watching this one, and get ready for the competition on November 7 onwards. Okay, so for letter B, application letter B, complete the following. All dogs are mammals. Spot is a dog. What's your conclusion? Complete the following by way of deductive reasoning. Okay, next, for number 2, students have a wash day every Wednesday to allow them to wash their school uniforms. Today is Wednesday. What will be your conclusion? By way of deductive reasoning. Number 3, all students are eligible to be in the dean's list. Romark is a student. Then what is your conclusion? If all quadrilaterals have 4 sides and a square have 4 sides, therefore what? So what will be your conclusion? So quad, from the word quad, means 4. Laterals mean sides. So 4 sides. Okay. Number 5, all numbers are divisible by 5 if the last digit of a number ends in 5 or 0. The number 540 ends in 0. Therefore what? That's a conclusion. By way again with deductive reasoning. For letter C, application, you are tasked to solve the unknown variable. Okay, so this is where language of mathematics has to apply, such that this x is no longer a mathematical operator, but instead it is a variable. That is the unknown variable which you are going to find the solution set. When you say solution set, you are going to find the value of x that will satisfy the right member of the equation. In Tagalog, kung ano yung value ng x, ano kaya ang value ng x sa left member ng equation para ma-equate or para ma-satisfy niya ang value ng 47 which is sa may bandang kanan ng equation. We call that in English finding the solution set. Okay? Number 2 also, you are going to find x but take note of this symbol. Okay, this is what we call inequality symbol. Okay, I will teach you how to evaluate inequalities later on so that you can answer this properly. The same for number 3, you're going to find the value of y so that the left member will tell that what will be the value of y to make the right member equals to 30. Number 4, 22 minus the product of 7 and m is equal to 1. So this is, I think this is translation. Okay, translation. 22 minus the product of 7 and m is equal to 1. What is the value of m? So again, pag hindi kayo marunong mag-translate, what is 22 minus the product of 7 and m is equal to 1? Kung wala kayong magawang equation, hindi nyo masosolve si m. Ano kayang itsura ng equation nito? So, nasa sa inyo yan, how to solve it. For number 5, the difference of 7 and a number equals the number plus 5. So, how will you represent and find the unknown variable? Clear? Okay, so find the unknown variable. Okay. So, I will make a separate video to deal with these problems, and if you can master that one, then everything for this C here you can solve it. Okay. Then for module 3 assessment, read carefully and determine which of the following statements are inductive or deductive reasoning. Write your answers on the space provided before each number. So like for an example, for number 1, all cookies are made with sugar. Cream O's are cookies, so Linda knows cream O's are made with sugar. So, what is this? Is this inductive or deductive? Okay, is it from, kung inductive siya, from specific going to general. Okay, kung deductive naman, from general to specific. Yun lang ang guide, key or keyword ninyo para ma-differentiate yung dalawa. Okay, the same for number 2. My math teacher of last semester was a woman. This semester, my math teacher is a woman. Therefore, all math teachers are women. So, what is that? No, deductive or inductive? Then, Miss Sandy, Miss Clara, and Miss Sally are teachers. They are all nice. Therefore, all teachers are nice. Okay. Number 4, if all organisms are made of cells and humans are organisms, then humans are made of cells. What is that? Eagles, number 5, eagles, parrots, and doves are all birds. They are all birds, therefore all birds can fly. Then for letter B, sketch the next figure. No, it's just the continuation of, I think this is similar to what we did here. Where is it? Where was it that I think similar to this one, no? So the pattern, okay? So here, the same, we will do that. So sketch the following pattern, okay? So here we have one triangle, two circles. One triangle, one circle, what's next? Okay? For number 2, the pattern is like this. 1, 2, 3. So what's next? This must be a box here. Okay, what's next? For number 3, I think 3, you have this, then what's here? Okay, you have here this one. So what is here? This one. So what's the next pattern here? Okay. So that's it. For letter C, write the next 2 figures of each of the following series. 5, 10, 20, 40, 80, 160. Then what is this 2? Same applies for 2, 3, 4, and 5. For letter D, for each of the following, solve the unknown variable. Actually, variables, because what is unknown here is what the unknowns here are x and y. Okay, so what will be the value for x and y so that these two equation will hold true? Okay, the same for number 2, you have unknown x and y. So what will be the value for x and y to make these two equations true? For number 3, this one, how many unknowns you have? Only one. Okay, what will be the value of m here so that the left member of the equation will be equal to the right member of the equation? Number 4, also one unknown, only x. What will be the value of x so that the left member of the equation will be equal to 10 on the right member of the equation? Here also, what will be the value of y so that this left member of the equation will be equal to the right member of this equation, which is equal to 1? Okay, then I think this one is not okay, not this one. Okay, I think this is the last part. Okay, so that's the last part. I think that's it. So expect another video to be released anytime. Maybe hopefully a day after, or if I can still continue doing this video, I can release also at the same time. So so much for that. That will be all for this for module 3. Take note again, I'll give you another one video on how to solve these unknowns. No? Okay, that will be all. Thank you. Bye bye.